Hello everyone, welcome to my channel Standard Physics Academy. In this video, I am going to discuss some numerical problems of class 12th NCERT book lesson 1. The first problem is, what is the force between the two small charged spheres having charge 2 into 10 to the power minus 7 coulomb and 3 into 10 to the power minus 7 coulomb placed 30 centimeter apart in air? So here we have to find the force between the two charged sphere. Q1, Q2 placed at a point A and B. Q1 is 2 into 10 to the power minus 7 coulomb and Q2 is 3 into 10 to the power minus 7 coulomb, and the R is 0.3 meter. From Coulomb's law of force, we know the formula F is equal to this. After putting the values of this 9 into 10 to the power 9, Q1 2 into 10 to the power minus 7, Q2 3 into 10 to the power minus 7 divided by 0.3 whole square, and after simple calculation we are getting F is equal to 6 into 10 to the power minus 3 Newton. So the force between the two small charged sphere is 6 into 10 to the power minus 3 Newton, and the force is repulsive in nature because the charges are like in nature. So this is the force between the two small charged spheres. And the second problem is, the electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. What is the distance between the two spheres? So here Q1 is given 0.4 microcoulomb. This is equal to 0.4 into 10 to the power minus 6 coulomb. Q2 is given minus 0.8 microcoulomb. This is equal to minus 0.8 into 10 to the power minus 6 coulomb. And the force is 0.2 Newton. It is F12, force on first charge by 2, F12. So by Coulomb's law of force, simply put the values of Q1, Q2. F12 is given 0.2. This is 9 into 10 to the power 9. Q1 0.4 into 10 to the power minus 6. And Q2 0.8 into 10 to the power minus 6 by R square. Just take out R square, and by the simple calculation, we are getting R is equal to 0.12 meter. So the distance between the two spheres is 0.12 meter. And the second is, what is the force on second sphere due to the first? Means we have to find out F21, force on second by 1. Force on 1, 2 is 0.2 Newton. We have to find out F21. So here the force F21 is equal to F12. The force F21 is equal to force F12 is equal to 0.2 Newton. Means the force is equal, and the force is attractive in nature because the charges are unlike. So this is the problem based on Coulomb's law of force. Now let us discuss another problem of the textbook. Two isolated charged copper sphere A and B have their centers separated by a distance of 50 centimeter. What is the mutual force of electrostatic repulsion if charge on each sphere is 6.5 into 10 to the power minus 7 coulomb? Here two charges Q1 and Q2 located at the point A and B, and charge on each sphere is given as 6.5 into 10 to the power minus 7 coulomb. Means charges are 7. Q1 and Q2 is equal and separated by a distance 50 centimeter, that is 0.5 meter. So from the Coulomb's law of force, just putting the values of all these things, F is equal to 9 into 10 to the power 9, 6.5 into 10 to the power minus 7 whole square divided by 0.5 whole square. And after simple calculation, we are getting F is equal to 1.521 into 10 to the power minus 2 Newton. So this is the force between the two copper sphere. Second part is, what is the force of repulsion when each sphere is charged double and the distance between them is halved. So here the charge on each sphere is getting doubled. So Q1 into Q1 is equal to Q2 is equal to 2 into 6.5 into 10 to the power minus 7 coulomb, and R, the distance between them is halved. So R is equal to 0.5 by 2 is equal to 0.25 meter. Then again from the Coulomb's law of force, putting all the values, Q1, Q2, that is 2 into 6.5 into 10 to the power minus 7 whole square divided by 0.25 whole square, and after a very simple calculation we are getting F is equal to 0.2434 Newton. So this is the problem and this is the solution, very important.